Thank you. A couple of years ago, my team was working with a new client, and there was a 3-node MarkLogic cluster in production. Things were going along fine until one day they did a deployment, and it failed. Well, that's odd, that's unexpected. It turned out that the node we were deploying to was down. Well, didn't we set up high availability? Didn't we set up replica forests? Everything should be fine if a node is down. Turned out 2 of the nodes were down. One of them had been down for 2 months, but there was no monitoring. There was no observation of how the system was doing. And as a result, we learned that lesson about, even early on in the project, it's good to set these things up early on, make sure you're catching them, make sure you're going to pay attention. I'm Dave Cassel. I'm CTO and co-founder of 4V Services. Today, we're going to have a very practical talk about tools and techniques we can use for MarkLogic-powered applications to observe what's going on and catch any problems before your users do. Before I get into the tools and techniques, I want to run through a strategy I've seen used in some places and see how many of you this resonates with. So we have here a user who's interacting with an application powered by our database, and everything's going great until it's not. Something goes wrong, and there's a problem. So what does our user do? Well, they get a little grumpy to start, and they call. And that call goes to our support team, who now has to go find out what's going on, track down that little demon, slay that beast, and once that happens, then our application goes back to a happy state, and now we're all well and good, right? Application's back to happy, users are happy. Not quite. That user is going to remember, right? They're going to remember that this happened at some point, and every time it happens, there's just a little thing in the back of their head that said, that application caused me trouble last week, or last month, or last year. And that can accumulate over time if we're not careful. This is the strategy of using our customers as our error notification strategy. I won't ask if any of you are using that strategy now, but has anybody ever worked at a place where that strategy was used? Yeah, a couple, yeah, okay. It's an all too common strategy, but there are better approaches. We're going to talk about that. We're going to start off with some really straightforward stuff. Again, very practical talk. We're going to start with things that could make your application go wrong, and we're going to build up to, we start with that basic prevention and work our way through. Thinking about the things that can go wrong in an application. In MarkLogic, we're working with JavaScript and xQuery. Common factor in both of those is that they're interpreted languages. So how do we know when we've got a syntax error in one of those languages? You run the code. It's not until you run the code that you might notice that there's a problem like that. So it's really important that we have a good set of scripted tests so we can ensure the code actually runs. We want to make sure we do that before deployment time. Logical errors, the next step. Okay, our code is syntactically valid. We want to know that it actually does the right thing. Again, we want to figure that out before our users find out that it doesn't. So we're going to make sure we run those functions and make lots of good assertions. There's a great MarkLogic unit test framework that we can use to build out those sets of unit tests. And the more of that we build out, the more code we covered, the more the application we cover, the more confident we can be that the application actually does what we need it to do. So we're going to cover a variety of scenarios as we build the code, and then as we find bugs, we're going to add new cases so that we can prevent regressions. And again, we're going to build that confidence that we know what we're delivering to the users actually does what they're looking for. One of the benefits of this is that when it comes time to refactor, to rewrite, to improve the application, we're going to have some basis for confidence that the application still does what we need it to do, and that's pretty helpful. Of course, things will go wrong. That's inevitable in software, and that's okay. We plan for it, we handle it right. So making sure that we cover error handling well is useful. Part of that is still with that scripted testing. Let's make sure we test those error cases, make sure that they're handled gracefully, make sure that they return useful error messages. One of the things that we generally do at 4V Services, especially in our JavaScript code, we like to build specific error classes in the JavaScript code so that when we throw an error back up to the service level, we're not just getting, hey, exception, something broke. We're getting something very specific that tells us what the problem is. And that allows us to send back useful, meaningful error codes. Have you ever worked on an application where anytime something goes wrong, you get back a 500, right? It's just that very high-level generic error code that says, something broke, that's all I can tell you. If you're working with an application as a developer, that can be a little frustrating because you have to go dive into codes, dive into the logs and stuff. If you're a user, the application's not going to be able to tell you anything more helpful than that didn't work. If we're using useful error codes, then we can tell the user there was a conflict. That wasn't found, right? We can do a variety of different messages that give the user a little more understanding of what's happening, and they may be a little more patient with the fact that it didn't actually work that time. You know, they might have a sense of whether it's worth trying to just run it again. We also like recording errors in the database. MarkLogic being a database, we've got that right there. And that gives us a couple of handy features. We can do dashboards. So administrators can often visualize right from the application, here's how things are going. Here's how many errors we've encountered. Here's the kind of things that are going wrong. But we can also enable retries in many cases. We had a problem in our ingest. Well, we can keep track of that with an error document in our database. We can give it another try in 10 minutes, 30 minutes, an hour, whatever it might be. This allows us to get past things like, we tried to pull in this data, but the network was down. That's fine. We can try it again in a little bit. And over time, we'll accumulate that record, and we'll be able to see where are the problems. This is much more helpful than having that information in the logs, partially because it's a lot more accessible, but also because logs often get archived, and we want to make sure that we have access to that information before it goes away. One of MarkLogic's hallmarks is security. So we always think about making sure that people are given access to the right things, denied access to the right things, the actions and privileges, it's the same kind of requirements. We want to make sure that we're doing those things right. This is part of our testing. We can be doing scripted testing to cover this. Can and should. So when we're writing unit tests, we often set up test users. MarkLogic internal security allows us to create individual users. We can assign them roles. We can run the actual tests as legitimate users. We can make sure our setup code is setting correct permissions. And this way we get realistic tests to demonstrate that not only does the application code do the right logic, but it's applying security correctly for the different categories of users that we have. Moving on to capacity. This is the next level of things, right? So once we've gone through our testing, we've got a good battery of tests. We're confident that the application will run. It's going to do the right thing. We're confident in security. We need to make sure that the infrastructure that we're running on is going to provide the resources needed. There's a variety of things we need to pay attention to, starting with disk. We need space for content as well as the indexes. And not just the originals, but we often have replica files. So we need to make sure there's enough disk capacity for that, as well as backups. Backups are often stored in a different location. And if that's something like S3, we can treat that as almost an infinite resource, so we don't have to worry about making sure we have enough. But if it's not something like that, we need to make sure that we have enough to do our backups, to retain a couple of copies, and just ensure we have that covered. But disk isn't just about size, it's about speed. So let's ensure that our I/O is satisfactory. And memory, I often find memory is the constraining factor, especially in cloud-based applications. Memory is expensive in the cloud, so we want to make sure that's there because this is critically important for the caches and the indexes that MarkLogic uses to run effectively. Naturally, CPU comes into play. With MarkLogic, we talk about E nodes and D nodes. E nodes are evaluator nodes. This is where the churning through the data happens. The D nodes, they maintain the data and do the initial step of many searches. But we need to make sure that we have enough of that CPU capacity. So how do we know how we're doing on these measures? MarkLogic gives us some really useful tools. We're going to start with the MarkLogic dashboard, and we'll take a look at each of these in a bit more detail. The dashboard is a really nice way to say, how do things look right now? If we want to look back in time a little more, we have a history application. There's the management API, which is great for ongoing observation of how the system is running. And of course, we can always dive into the logs. Looking at that MarkLogic dashboard, it comes with 3 tabs: query execution, rates and loads, and disk space. I think I spend most time on the disk space. This is one I check regularly just to make sure that we're okay, that we've got plenty of capacity. And we'll get a different line here on the upper left for each partition that's been mounted anywhere in the cluster. Very helpful resource, just shows us at a glance how we're doing. And the lower part of the graph breaks it down into how are we using that space. You'll notice that on the left, we can see we're not using all that much space, but as we look over on the right, more of it is consumed by that forest reserve. As MarkLogic does its merging process, which is part of the multi-version concurrency control that it uses to power ACID transactions, it needs a certain amount of space to work in order to maintain itself. So what we observe here is if that forest reserve takes up a bunch of space and the free comes down to 0, MarkLogic will start to get a little upset, and it'll say, wait a minute, I'm running low on space. I may not have enough space to do the merging that's important. So we want to check in on that occasionally. Again, this is a good way to just check what is the situation right now. We'll see how to do more active monitoring. Another thing I like about this view is the forests. There's some applications will have multiple applications deployed to the same MarkLogic cluster. Each of them will have their own set of forests. And we can see right here in a nice graph how much space each of the applications is taking up. In this case, I have a single application, so it's 8 forests all for the same application. But I might have a different situation where I've got some other content forests, and maybe they only come out to here. And maybe it's perfectly reasonable that this one takes up so much more space. Maybe that's a sign of something going on. Maybe it's a sign that I need to think about my allocation of resources. So a useful view. MarkLogic 12 introduces a nice new feature to help us with disk monitoring. It has a background process where it'll write temporary files and read them automatically in the background. And if it notices that the reads that it's doing are corrupted in any way, then it's going to recognize that there's a problem with the disk. There's a problem with a corruption in the disk. And we can configure that MarkLogic node to automatically shut down. So in a higher availability scenario where we've got multiple clusters, that means, multiple nodes within a cluster, that means that we can have a node that has suspect disk storage take itself out of the equation and allow the replicas to pick up and do their work. It's a handy feature. The important thing, of course, is to notice when that happens so that we can address the underlying problem and get things back to where they need to be. This is another nice new feature in MarkLogic 12 to give us more visibility into how resources are being used in terms of memory and disk. I mentioned that indexes play a big role in the memory usage. And on a database configuration page now, the status page, we have this Show Index Memory Usage button. If we click on that, we're going to get a breakdown of here's all of the indexes that are configured on this database and how much space they're taking up in memory and on disk. This is a simple, small application running on my laptop, so you can see the numbers are pretty small. But you can imagine that if you've got a large application with many indexes, this is a great way to be able to look through and see what's consuming those resources. You can imagine also taking the next step and saying, this index here that's taking up a lot of space, a lot of memory, a lot of disk, we don't actually use that one very much. Maybe that's a really good candidate to replace with a TDE view or some other approach. So it gives us that insight, that observability, to really understand how the system resources are being used. The history application is a great way to look back in time. So your customers come to you and say, something went wrong, we've got a problem, what happened last Tuesday? Well, we can look at the logs, but it's really helpful to be able to look and see at a granular level what was really going on then. In the upper left, we can specify start and end time as well as the period. Raw is very frequently checkmarked information, hourly and daily. You can guess what those mean. So if I'm looking at a very specific point in time, I'll often narrow in on the time, give me the raw view, let me see what's going on. What we're going to see here is the effect of running an MLCP job that copied a bunch of data into one of my MarkLogic databases. Again, this is running on a Docker container in my laptop, so it's not real big data, but it's enough to make the point. CPU didn't have to work that hard. Not real complicated, there's not much processing happening. But the I/O, predictably, this is all about loading data. We're reading things off the disk, we're pushing them into the database, we're doing commits. The memory is climbing as I do the MLCP job, and then it settles out a bit as it no longer has active things in memory. As we continue scrolling down, we see that the app server request rate got a lot of requests when I kicked off this job. A lot of MLCP throwing requests at this MarkLogic app server. It goes up, levels out for a little bit, and then tails off. App server latency stays pretty low because this didn't really take long for any of those individual requests. They were fairly simple. The test server wasn't in play. I'm going to keep moving down to the part I find most interesting about the history app. So the fragments and storage footprint, predictable, right? I'm doing a data load. Of course, those are going up and staying up. That makes sense. These last four, the lock rate is telling us how many read locks and write locks we use for the application. We're doing a data load, so it takes a write lock on a URI, writes the document, releases it. You'll notice that the lock weight load stays very low, basically 0. This indicates that there's not much contention among different processes as they're trying to work. If we see that one bubble up, it's an indication we've got different processes that are trying to get locks on the same URIs. So the fact that that stays flat, that's great. That's what we want to see generally. The lock hold load, you'll notice that graph is very similar to the lock rate. Lock hold load tells us how long is a lock being held once it's taken. So it makes sense that it parallels the other one, right? We get a lock, we write the document, we release the lock, done. Doesn't hold on to them for long. If you've got a longer running process, you can imagine that graph stretching out after the locks have been taken. This last one. This is one we really want to pay attention to, the deadlocks here. If you ever see the deadlocks above 0, that's something that's worth investigating. We can have multiple processes that are working with MarkLogic, trying to get read locks, trying to get write locks, and if we get 2 that are each waiting for the other one to release a lock so that they can get a lock, then they are in a deadlock contention. They cannot remedy it themselves. What happens in that case is MarkLogic will actually terminate one of those processes, allow the other one to finish, and it'll restart the first one. So this is obviously not a very efficient process. We don't like to see that. So there are ways, typically by running XDMP lock for update or something like that, we can ensure that we're preventing those deadlocks from happening. Prevention is always better than cure when it comes to this. So that's if we want to look back at something that already happened, but we really want to observe and monitor in real time. So we've got our MarkLogic cluster, and the management API is one way that we can talk to that. So imagine we've got an observer of some sort that's sending requests to that management API, getting back responses, and as appropriate, it can then send notifications to someone, an administrator or someone else with the ability to do something about it. One of my favorite URLs for this in the management API is the manage v2 view equals health check, format equals JSON. So the health check view tells us for every database, for every app server that's running in MarkLogic, is it healthy? Real simple metric, really easy to evaluate, and really useful to know. Because if anything ever comes back false, we want to jump on that. Again, let's find it before our users do. I mentioned the idea that that observer should alert someone. Let's think about that for a minute. Warnings, definitely better than forensics, right? If we can find out that something is going wrong and address it before our users find a problem, that's great. If we have to wait till somebody reports a problem and then we're looking back in the past, that's not nearly as satisfying. It's not as good for us. It's not as good for our users. But we do have to be a little careful about these alerts. Anybody ever on alert email lists? Do we know what we mean by alert fatigue? It's quite possible to have a situation where your system is sending you 10 alerts a day saying, everything's good. Thanks, that's great. How quickly do we just naturally as human beings put a rule into Outlook that says take that and shove it over in a folder there so I don't have to look at it anymore? We don't want that, right? We don't want to send so many alerts that we train ourselves not to pay attention to them. When alerts come in, we want to notice. And it's not just the frequency, it's the content. What do we put in an alert? I'm going to start off with an example of what not to do. Ingest error. Thanks. Something went wrong during ingest. If I get this as the person who's on call for support, what am I going to do with that? That's not much to work with. Let's look at a better example. Now here we go. This is a real one, by the way, that I've redacted a couple of details. But this one, we start off with in the subject line, EDL dev. I've identified not only the application, but the environment. This is the development environment. I can take a breath. If this is production, you have my attention, right? Failed to write document to MarkLogic. Okay, that tells me something. I can tell you something else about this error, because I wrote it. I know that this subject is unique. This string occurs exactly once across the entire application, across all components. I can take that string, search for it. This one happens to come from Apache NiFi. I can search through the flows and be taken to the exact location where this problem happened. And I make a point of always doing that. I've got plenty of information down here about the details of this particular error, which data was affected. But I've also got this note. All right, so failed to send a JSON document to MarkLogic. Okay. This means that the document was read from the source database, but not saved. Now I understand the impact of this error. There's a couple other things I like to do that this one does not show. What should I do about this? Do I need to do anything about this? A lot of my error messages will actually say something like, this will be retried. If this message reoccurs, here's what you need to do. Because I'm not always going to be the one who receives this. It's often going to be somebody else. It might be me 6 months after I've written it, and I want to make it as clear as possible when this happens, what is the impact? Is this a drop what you're doing and do something about it now, or is this keep an eye on it to see if it keeps happening? So having that kind of information in your alerts is really useful. One other thing I'll note, the to line, this first one was sent to me. What if I'm on vacation? What if I'm sick? What if I'm busy? Over here, we've got 3 people. Even better would be a notification list, but the key point is this alert goes to more than one person. The trade-off, the other side of that coin, is to be conscious of the diffusion of responsibility effect. If we send this email alert to half a dozen people, all 6 of them might say, somebody will get it. We don't want that. We want to make sure that somebody at all times knows that they are the one responsible for addressing these. That can be rotated, it can be an assignment, whatever it is, there should be an understanding of who is it who needs to pay attention to this. Going past alerts, I've mentioned logging a couple times. It's important we write good log messages, that's standard practice. And we want to make it so that those log messages really help us observe what's going on. XDMP trace is a nice feature in MarkLogic. It's been there for a long time. We can set a flag and then an error message, a log message. And in MarkLogic, in the admin UI, we then have the option to go in and say, let's turn on this particular trace flag. And so previously it wasn't writing those logs, now it does, so we're able to get more logging information without having to redeploy the application. We can just turn it on. I find this really good for complex code that usually works. If it doesn't work, it's really nice to be able to pop in there, get some more information about what's happening, and get that better view. Good prefixes are important. Similar to what I said about the alerting message, I've got something distinctive in there to point me to exactly where is the problem. A bad example of this, xdmp.log brens result. So all I get in the log file is maybe it's a JSON object, maybe it's a string, maybe it's nothing at all. What do I do with that? My log messages usually have something like this. I've got the name of the code file that was running. Here's an indicator which function I was running. Here's the name of the variable that I'm providing, and here's the value. So now when I see this in a log file, I can really trace that back to exactly what was going on in the application. I've got much better stuff to work with. I actually have a blog post out there talking about best practices for logging in MarkLogic, so I invite you to check that out. Looking at the logs is great when we think to do that. Better yet, come to us. Bring the logs to us. When we have an application, we'll typically have, let's say we've got some number of MarkLogic nodes. We've got an application middle tier. Maybe it's running Java, maybe it's Node. We probably have some kind of data orchestration tool like NiFi. Each one of these pieces is writing its own independent log files. And it would be really nice if we could get those log files into one common place where we can see them nice and easily. How do we get them there? The traditional approach is you install a little agent on each one of your servers, and it sends the information to this common place. Once you've got it in a common place, now we can set up a dashboard. The dashboard can be set up to send alerts. Now we've got a way of observing logs across our entire application. It makes it a lot easier to do that analysis, to find out what's going wrong. Now, this pattern, I'm sure a lot of you recognize this as this pattern has been established for a long time, right? You may be familiar with the elk stack. I wish I could take credit for this picture. I'm not that artistic. But the elk stack, it goes way back in terms of a specific set of tools where Elasticsearch is a place that will hold a bunch of logs. Logstash grabs those log files and pushes them to Elasticsearch. Kibana lets us build that dashboard. Turns out Logstash is actually fairly heavyweight, so there was some reluctance to put that onto all these different servers. But the pattern holds. There's several different tools that we can use at each of these stages. So example, FileBeat is a lightweight agent that we can put on each one of our servers that'll push that log content to that central location. The format used by MarkLogic for its access logs and even its error logs is something we can pretty easily parse the file beat. So it's nice and simple to get that. Something else we haven't talked about observing yet. What do we have so far? We've done our testing. We're confident that the application is working correctly. That's great. We've got enough capacity. Cool. When something does go wrong, we know that we're going to detect that. We've got ways to see when things are going wrong. There's one thing left. The users. We want to make sure that the users themselves are actually enjoying this application, benefiting from it, getting good value out of it. There's a variety of reasons why our users might not be using the application. And so some reasons for low engagement, we can start with they don't know. They don't know it's there. So we can address that through education, webinars, newsletters. We can send out messages within our organization to point out that, hey, this thing is here, it fulfills this role, here's how to use it, that kind of thing. But it might also simply be that the application doesn't address the need that the users really have. And ideally, we find this out before we get too far into building the application. But part of rolling it out can be webinars, it can be usability testing, and the feedback we really want to get is, that's cool and all, but you know what I really want? Right? That's gold. Bring that on. We like that. The one that we really want to worry about, though, is we've built something, it's supposed to be addressing the need, but it's not delivering good results. We heard some discussion this morning about metrics, right? How do we know that those Gen AI tools are providing accurate results and useful results? Well, we want to do that for any kind of application, whether it's AI-powered or not. So observing users is an important piece of this puzzle. We can track metrics about their use, and that includes things like how many unique users do we have? What are the different kinds of searches that are being run, and how successful are those searches? And successful, that could mean that if you come back with no results, that's probably not a successful search. But if you come back with a bunch of results, that might or may not be, right? So we also want to pay attention to, are the users interacting with our results? It's a good practice in many organizations to anonymize the metrics that we track. A lot of organizations have some rules about this. Your mileage may vary, but this is something reasonably simple where we can take usernames, we can hash them, we can make it so that this is not traceable back to an individual, if that's appropriate, but we can still gather all these metrics even with those rules in place. Doesn't do us any good unless we review the metrics, right? So part of observability is actually the act of observing. So we need to make sure that's part of our process. If we're not getting good engagement, then there's a couple things that might be, but one of them is that this might be an indication that we're missing some data. I think there was discussion this morning about one possible scenario is we're seeing a gap in the data we've collected for our application. And by tracking metrics, by thinking about what does it mean when our users are not engaging with this content, when they're searching for this, that can really tell us, here's what we need to do to make this more useful. And it might be that the application had been really useful. It might be we were on track, but the landscape has changed. Maybe it's because we went through some M&A activity and now we've got a new group of users. Maybe the business scene has changed, whatever the cause may be. But it's something we want to pay attention to. For implementation, what I've done for a few cases is use triples. MarkLogic's got some great capability there. Lets you ask some really interesting questions. And since we're at the Progress Data Platform Summit, I thought it appropriate to point out that this stuff applies really well if you're running MarkLogic and Semaphore and such like in the cloud. The Progress Data Cloud does include access to the admin UI, query console, the dashboard, the history application. All these pieces are available through that platform. The one tricky thing is you can't put your own local agent on there. I did see some points on the slides this morning about OpenTelemetry. And that's brand new for me, so I can't speak to that, but it sounds very promising. All right, so a couple of takeaways. One is automate those tests. It's great to have tests, but we really need to make sure they're run. It's easy and natural to start skipping that if it's not something that happens automatically. We want to make sure it does. Scheduling regular capacity reviews, not just to do it, but here's a key part. Do you know when in your business's cycle the budget decisions are made? Whatever that time is, a little before then, you want to figure out that you need more CPU or disk or whatever. If you know that, if you figure out that you need more of that a month after the budgets have been set, you're waiting 11 months before you get another shot at it. So understand your business's rhythms and schedule your capacity reviews around that. Make sure you're actively alerting. Don't wait for your users to notify you about problems. Find them before they do. Right, so that wraps it up for me. Again, Dave Cassel, CTO of 4V Services. We work with MarkLogic and Semaphore customers. We've been doing that since 2018. And we have a booth in the back of the room upstairs, so love to chat with you about your use cases. That's what I've got. Questions, anyone? I think you were nodding vigorously when I mentioned OpenTelemetry.
I'm the product owner for Proxy.
Oh, perfect.
OpenTelemetry is a key thing we're providing with the platform.
Okay. OpenTelemetry is a key part of what we're providing with the platform.
Yes. MarkLogic, of course, has OpenTelemetry support coming, but it will be able to pull that right up.
Fantastic. All right, great. Other comments, questions? Gary.
So, can you comment a bit? Some of this is. All right, there we go. So, welcome. So he really is taking a picture. All right, right. Dave, so much of what you're talking about is a good bit of process orientation, which is absolutely necessary irrespective of platform that you're using. But can you speak to time to resolution with respect to the MarkLogic platform? Are there any strengths or capabilities there that actually have made this independent of process still significantly faster to resolve? And what is the longest, what is the biggest challenges that you faced when you encounter a problem in MarkLogic? What is the typical turnaround time that you will see into resolution?
Okay, interesting. So, yeah, I find if we apply these practices, and to Gary's point, a lot of these practices are not unique to MarkLogic, right? The idea that we want to capture log files and do alerting, do analysis of that is platform independent. It goes everywhere. Some stuff I love about how this applies to MarkLogic. For me, the code is very accessible. So when we do discover something going on, it's relatively easy to get in there and do some work with it. It's easy to come up with a test, expose the problem, resolve it, and get a deployment out there quickly. The data agility aspect means that we're not going to have to worry about conflicting schemas. We can really get in there and work with it easily. I'd say one of your questions was, what do I find most challenging? What are the things that that are the hardest to resolve? I'd say when there's delays in that capacity review, capacity planning, and you end up with, let's say, a 3-node cluster doing the work of a 5-node cluster, that's not something you can typically turn around overnight if you're on an on-prem. If you're in the cloud and you have the budget for it, then it's a relatively easy thing to spin up a couple more nodes and you can resolve that quickly. But some of my clients are operating on-prem, and so that's a bit more of a runway. What is the best way to stay in front of the capacity planning challenge? So we talked about using the management API for observing, and that management API includes several endpoints that allow us to say, how are we doing on disk, on memory, on a variety of metrics. We track them, we query them regularly, we track them, and importantly, it's not enough to collect, we need to review, we need to take action on them. So I would say active monitoring with the management API. Okay. And I think that,
We got 4 minutes.
oh, okay.
Maybe one more question?
All right.
No?
One more question?
Anybody else? No? All right. As Dave said, stop by his booth if anything else comes up. Thank you, Dave.
Great. Thanks all for coming.